All right, hey gang, coming to you now with our first lesson of the year in geometry, and I don't want to waste your time. I want to get right into it. But what we're going to be working on over the next couple days really is developing our understanding of basic terminology. Okay, if I could specify one of the main differences between Algebra 1 and geometry is that there are a lot of terms in geometry. So I'm going to make a more concerted effort this year to come at you guys with review games for just basic terms to make sure that you are understanding how these terms fit into the rules or the laws or what we call the theorems of geometry. And so, as I said before, I don't want to waste your time. Let's just start talking about these different terms here. So, as I remove my talking head from the video, I want to look at the main. Yeah, these are all good terms here. They're all terms that you're going to see on your first chapter test in some way, shape, or form. But these three right here actually have a special relationship, and we'll talk about what that relationship is here in a second. So what is a point? A point is a location in space. Okay. Now, when you think about a point, that point could be as small as the tip of this this pencil head. Okay. That point could be I'm pointing to the tree outside, so that tree could be a point. If you've ever used Google Maps before, the point could represent the entire city of Findlay. That point could also represent the entire world, okay, or the galaxy. So what we also know about a point is that it has no defined size. That size can vary based on what we're looking at, okay? Now, in most of the models or diagrams that we're going to be looking at, a point is going to have a little dot with a letter next to it, oftentimes a capital letter. I'll put R, or I could put, let's just say W, okay? And if I was to answer this in a test question or a quiz question, you would say, hey, I'm looking at point R, you would actually write that out for me. Point R, point W, okay? Some people will just put down W or R. We'll be specific what we're talking about here as we move through that. So again, it has no defined size. A line is a series of points that continue in opposite directions. In opposite direction forever. Okay. For all of you Sandlot lovers out there, forever. All right. Now, what we're trying to say here is that it doesn't have a measurable length. It really has no beginning and no end, okay? Now, how many points make up a line? Well, I hope you know that 2 points help to define one line. Can there be more than 2 points on a line? Yes, okay. But this is what we call our first postulate. A postulate is an accepted rule of geometry. We don't have to prove it, okay? It's a starting point. So 2 points make one line, all right? And so if I were to go ahead and do something like this, let's say that this is A, B, and we'll put a line right through it, okay? So this is the diagram here. And you wanted to identify this as your answer, you could go ahead and say line AB. Make sure you include the little symbol above there. You could also say line BA, okay? That's the same thing. It covers the same set of points. Or if I was to put a cursive letter at one end of this line, let's say line X, and I'm doing a lowercase x right there. You could also say line X. And you'll notice there I'm not using the line symbol above it because it's representing the whole line, okay? All right, a plane. And I'm not talking about the one that flies out in the sky. Bzzz. No. I am talking about a plane. Those of you that play football, the term breaking the plane of the end zone. Soccer, breaking the plane of the goal. Okay. Volleyball, not crossing over the plane to the other side. And so when we're talking about a plane, we're talking about a flat surface. Okay. That continues in all directions forever. Okay, so a flat surface that continues in all directions forever. Now, because the plane is not measurable because it continues forever, the line is not measurable because it continues in opposite directions forever, the size of this point is not measurable. We call these the three undefined terms of geometry. Almost everything we do in geometry is definable, otherwise it's not usable. But again, because they have these special characteristics, they're not measurable, we call them the three undefined terms of geometry. Sounds like a possible bonus question. Hint, hint. All right, now a plane, if I were to go ahead and draw it out here, a plane, a lot of times looks something like this, okay? It's drawn like a parallelogram. And before I go to my next point here, which is another postulate, kind of like the 2 points make up one line, I want you to think about a camera person, okay? And if someone comes to take your picture, and I think that these instruments were used more so when I was younger, but I know that people know what these are. Oftentimes they put their cameras on top of these. Do we know what they are called? They're called tripods. Now, why are they called tripods? Because they have 3 legs to them, okay? Why don't they have 4 legs? Well, the reason is if you have 3 non-collinear points, meaning 3 points that aren't in a straight line, if I were to do A, B, those 2 are in a straight line, but this one is not, okay? If you have 3 points that are not in a straight line, that makes up a plane. So if you wanted to identify this plane on a test or quiz and you wanted to say, hey, I believe the answer is plane ABC, you would just write it out like that, okay? Plane ABC. Now, there is another way to do this, kind of like the line up here, another way to identify the line, okay? Instead of using line X, like I did right there, I'm going to go ahead and put a little cursive lowercase a right here, okay? And I could also say, or plane A, okay? So those are 2 ways to go ahead and identify a plane right there. You can use 3 points that are not in a straight line, or you can just use the letter that's in the upper, or in one of the corners, I should say. Now, these 3, actually, I'll come back to that. We'll come back to the postulate I was going to get to. Let's talk about collinear, because that actually leads to this right here. Collinear. When I think of the prefix co, I think of co-captain, co-worker. So what does the prefix co mean? It means you do something together, okay? And when we think of the root word of linear is line, what we're saying are points that are together on the same line, okay? So points on the same line, okay? And so collinear points. If I was to add another point up in here, A and B are collinear right now, okay? In fact, 2 points will always be collinear. You'll always be able to connect them with one line. But if I would add a C, a D, an E, an F, you know, all those points on that line would be considered collinear, okay? But back to my point here with plane ABC, these points are not in the same line, okay? So we could say this, if we have 3 non-collinear points, this will always make up one plane, okay? 3 non-collinear points will always make up one plane. All right, now again, if that doesn't make sense to you, not a big deal, okay? We'll cover this in greater detail later on, but that's usually one that kind of trips people up at first, so we'll, like I said, cover it again, okay? So coming back down, my other terms that we need to know, coplanar and coplanar. Coplanar points, coplanar lines. Again, what does the prefix co mean? It means together, okay? And so the root word of planar is actually plane, right? I'm going to move my camera so we can see this a little bit better, okay? So I'm going to say coplanar points means points on the same plane. Okay, points on the same plane. And if I do coplanar lines, I'm going to say lines on the same plane. Okay, so you'll have a chance to identify those for me here in a moment. Now, an intersection, you guys know what an intersection is as far as cars, is where one road meets another, okay? But what I want you to think of when you think of intersection is where two things come together, or, and this one might even be more important, what is shared when they come together. Okay, so here's what I mean by that. If I were to go ahead and draw a line, and I was to draw another line, and I was to label these lines A, B, oh, move that out, A, B, C, and D. What would I call this point right here where they come together? That's the intersection, right? So I'm going to label that point E. And you could say something like this. You could say line AB and line CD intersect to form point E. Okay? So that's actually another postulate, okay, which is if you have two intersecting lines, it has to always be a point, okay? Now, to show you another postulate here real quick, and I hope this doesn't get too confusing, but I'm going to try, oh, that's upside down, that's embarrassing. Let's try this. I wonder if I can go and make this bigger. Oh, that's kind of gross. Okay, so I'm going to go over here in the corner and see if you can understand what I'm going to be doing here. This surface right here, this flat surface, this wall, okay, would represent a plane, right? So this entire front wall of my classroom is a plane. And this wall over here, this south wall, is an entire plane as well. And if you were in my classroom, I would probably say something like this. What's the intersection of those two? Well, the intersection, and you would point to it, you would go, oh, it's this right here, okay? This corner, which is where the two walls come together, would be considered the intersection of the two planes. Now, the question is this: what do we call that intersection? Which term have we talked about today that would reference that intersection? Well, if I place my finger along it and trace it, I hope we see that that intersection looks like a line, okay? So, I know I'm trying things that are a little tricky here today, but let's make this much smaller. Sorry about that. Should have paused it. Okay, and let's take a look back here. We can actually write this down. remember before I told you that a plane can be represented by a parallelogram. If I didn't tell you, I apologize. So we can make this plane right here, okay? And I'll say that this is plane C. And another plane, now I'm going to try to draw this as accurately as I can. If I was to draw something like this, okay, so what you see here is this is plane D, okay? Now, if I wanted to be really accurate with my drawing, I would go ahead and do this. Actually, I'll just get rid of all of it and draw it better. It would look like this. All right. Now, here's what I'm looking at. Let's say that this is S and this is T. Okay. This plane C, so this plane C intersects plane D at line ST. So I'm going to say plane C intersects plane D at line ST or TS, either way. Okay. Now, the reason why I changed this to a dotted line, we need to talk about this, and I'll show you another example here in a moment, is because this dotted line represents something in the background that we can't see from our perspective, but it's still there, okay? And as I noticed my drawing, I should have fixed this side as well. This right here should also be a dotted line, okay? And so again, this plane D is in front of this portion of plane C. I wouldn't see it, so I put it as a dotted line. Likewise with this one right here, okay? I'm not a huge stickler as far as you guys drawing. I understand some of you are really good artists, and some of us, not so much, which is okay. But what I will tell you, oh, there we go. What I will tell you is this, that when you look at diagrams, I will be making sure that you understand that the dotted line is in the background, okay? So just keep that in mind. All right, now, to finish this off, I did want to show you kind of what I was talking about earlier. So take a look here, see if I can refocus that. Try it again. Oh, there we go. Okay, and let me get my ugly mug out of the way. Boom. Okay. So as you look at this drawing right here, here's what I'm looking at. I could identify this plane as plane P, the simplest way I could do it. Or I could say plane VWZ. It's three of those points that aren't in a straight line. I could say WXZ. Okay. I could say WYZ, you know, any combination of those three letters as long as they're not in the same line, okay? So that would be a way of identifying the plane. This line right here, I could identify this line as line TX, or I could go ahead and say it's line R. So just keep that in mind. That's line R or line TX, either way. Here's a dotted line like we just talked about. Why is it dotted? Well, this plane right here, plane P, and this line TX is shooting right through it. So this portion right here, this point T, is actually above the plane. And this portion down here, if this was, let's say, Z, now Z is already there, let's say that this is R, point R or point S, okay? That would be below the plane. So you have to be able to look at the picture accurately. Here's another picture over here, okay? Dotted line, right? And so what we see here is that this line is shooting actually through the plane. And so Q is above it, S is on it, and R is below it, okay? Now remember, this line, we can either call it QS, SR, or QR. You can't use 3 points. It has to be just 2 points to identify that line, okay? So here's what I'd like you, well, I'm going to post the homework that I'd like you to work on for me. I realize this video is probably a little bit longer than I wanted it to be, but I appreciate your attentiveness. And if you have any questions, let's talk. All right. Have a good day, folks.